Today we study the concept of limit. Why we study the limit? What is the significance of limit? In calculus, we study the limit. What is calculus? Why we study the calculus? For understanding the nature, for understanding the laws of nature, we need the concept of calculus. So that calculus is invented by greatest mathematician of all time, Sir Isaac Newton, and Leibniz. Simultaneously, they discovered this great topic. What is calculus actually? If there are change, then to measure the change, the word calculus requires. It means calculus is the study of change. Calculus is the study of rate of changes. Rate means change is measured with respect to time. Thus, limit is an important tool to understand the calculus. Here we start to understand the limit. The word limit is dependent on such type of functions. For understanding limit, we need a function. Let the function may be f, but this function is not just a function, but this is a real valued function. It means this function is defined only in real numbers, real line. This is a real valued function. It means this function is defined in real line only. For better understanding, rather we initiate to understand the limit. We have an example. Suppose y equal to fx is a function. Then this function is represented as x squared minus 1 upon x minus 1. What will be the behavior of this function? Not only for all real numbers, not only for all values of x, but except x equal to 1. Because if x equal to 1, then the denominator becomes 0. Then if denominator is 0, then the function cannot be defined. Thus, we have the two possibilities. First, for x equal to 1, where function cannot be defined. But another one which does not equal to 1 for x. It means definitely this function has any value, any real value. Actually, this is the function, but for better understanding, we have the graph. Suppose this function can be represented as the graph 1, minus 1, 1, 2, what will be the graph of this function? The graph will be like that. This is the graph of this function. We know that in this condition, function cannot be defined, but in this condition, the function is defined. We factorize the numerator as x plus 1 and x minus 1, and in denominator x minus 1. Easily this common term is cancelled. Then we have only the term x plus 1. It means there exist two graphs. First graph for this and second graph for this. It is very interesting. It is a very interesting fact. It is a very interesting observation, because the beauty is hidden here. What is the beauty? The beauty is another graph also represented like the same 1, minus 1, 1, 2, and we know that the graph will be same. This is the figure 1 and this is the figure 2. But surprisingly, there is a difference in these two graphs. Can you tell me what is the difference observed in these graphs? Very fundamentally, we can see here, for x equal to 1, the graph cannot be defined, means the line does not continue line. This line has the hole, because at this point, exactly at this point, the word is very important, particularly or exactly. At this point 1, this graph cannot be defined, or this graph is defined with this hole. But here, this graph is defined without hole, because at this point, if x equal to 1, then the function y equal to 2. But here, we cannot define x equal to 1, then the y equal to 2. Why? Because here the function is not defined. It means very close to 1, maybe for 1.01, maybe 1.001, maybe 1.000002. Definitely the value will be there, but not 2, but very close to 2. Here the value is exactly 2, but here at x equal to 1, definitely the function is not defined, but very close to 1, maybe beyond 1 or before 1. Before 1 means 0.9, 0.99, 0.99999 and so on. Again, definitely the function has the value, but that value is not exactly 2. Definitely very close to 2, but not exactly 2. It means here again y very close to 2, because x is not 1 but very close to 1. If x is very close to 1, then y is very close to 2 in this figure. But in this figure, x is exactly 1. Therefore, y is exactly 2. This is the understanding. This is the basic concept requires to understand limit deeply. Then, what is the matter? How we can define this particular theory so that limit exists, so that limit requires, so that limit needs to execute the applications in calculus. If any time this type of conditions exist, then you think about the limit. Then what is the limit? It means limit is defined by limit x approaches to a. A is any point in this real line, in this real number line, and fx is the function which has the limit L. This is the definition of limit with these conditions. It means how it reads. Limit of the function fx is L. Limit of the function fx is L as x approaches to a. No, it's not a correct definition. A real valued function fx, a real valued function fx approaches, not exact, approaches to the limit L as x approaches to a, not x equal to a. Here we can see not x equal to 1 but approaches to 1, close to 1, near to 1, either 1.001, 1.001, 1.00002 like that, or 0.9, 0.99, 0.9999 like that, very close to 1, not exact 1, because at exact 1 the function cannot be defined. Therefore, the concept of limit exists, requires. Here, a real valued function fx approaches to the limit L as x approaches to a. It means here also we define limit as 2, and here also the limit is 2. It means how to solve this problem? Very simply, the limit of this function is 2. It means L equal to 2 is the answer. But this is not comes directly. By understanding the values of x, this and this conditions, we have the limit L which is 2. Therefore, never you think about x is equal to a. Never. If x does not equal to a, but very close to a, then what will be the functional value? Thus, the functional value will be fx is very close to L, or directly we define L. Therefore, L is the limit value. Therefore, L is defined as the limit. Thank you.